Now let's take a look at addition of real numbers. When we talk about real numbers, we mean any numbers that are on the number line, whether they be fractions, decimals, whole numbers, or integers, positive or negative values. Whenever we have real numbers that are being added together, we can think about them in terms of money. We can say, okay, how does money work? Once we think about it that way, things are a little more intuitive because that's something we handle every day. Let's say you have two positive numbers, and just to be a little more concrete about it, let's say I have $2 and then I find another $3. Well, then I have $5. Okay. All right, now, what if I had $3 and I spent $2? What if I said, okay, I have $3, but now I'm going to add something. What am I going to add? I'm going to add a debt. After all, I spent something. So when you have money, that's positive. When you owe money, that's negative. So if you add, you have $3, you spend $2, you're left with $1. Now, what if it's the other way around? What if I had $2 and I'm trying to spend $3? Let's say I have a credit card or a debit card and it's got overdraft protection. So let's say I'm actually able to spend more money than I have. Well, okay, I had the $2, I spent $3, that means I'm overdrawn. I actually owe $1. Right? So here, I'm overdrawn. If I spend more than I have, I end up owing money, negative $1. Okay. Now let's say I already owe $2. Let's say I'm already overdraft, and then I buy something else that's worth $3. Okay, so I already owe $2, and then to that I'm going to add another debt of $3. Well, then that's going to give me a total debt of $5. Okay, so notice that when I have two positive numbers, I end up with a positive. If I add two negative numbers, I end up with a negative. But if I have one of each, well, sometimes it's positive and sometimes it's negative. Okay, so how do we decide which is which? And also, more importantly, what happens when these stop being nice numbers? Decimals, fractions, irrational numbers, and so forth. Okay, so the analogy with money is nice to get some intuition, but a lot of times, again, especially if the numbers are not nice, like fractions and irrational numbers, it may not be a good idea to think about it in terms of money, just for the sake of simplicity. So, how do we want to think about them? Well, what we want to do is we want to distill down this idea into a couple of simple rules. In fact, there's only two of them. Whenever you're going to add real numbers, and this will be whether you're adding just integers or fractions or decimals or anything else. This will be true for any sum of any two numbers. To add two real numbers, it doesn't matter what they are, to add any two real numbers, what you want to do is you want to compare their signs. If they're both positive or if they're both negative, that's one category. If the two numbers have the same sign, you add their absolute values. Meaning you don't worry about the plus or the minus, just think about the number. 2 and 3 make 5. 2 and 3 make 5 in both cases. But then, once you've added the absolute values, you're going to go ahead and keep the sign of the bigger number. You're going to keep the sign of the numbers that you had. Here you're adding two positives, so your answer is positive. Here you're adding two negatives, your answer is negative. Again, going back to the analogy of money, if you have money and you get more money, you have a bigger amount of money. If you have a debt and you acquire more debt, you have even a bigger debt. So you keep the sign of whatever you started with. If the two numbers have the same sign, add their absolute values and keep the same sign. Keep their sign. Now, what if it's not the same? What if the two numbers have opposite signs? One is positive and one is negative. Okay? Well, then what you do is you're going to subtract, because notice, if you have money and owe money, those are working against each other. You don't add the amount that you owe to the amount that you have, you subtract. Okay? So if the two numbers have opposite signs, you subtract their absolute values. Notice here, 3 minus 2 is 1, 3 minus 2 is 1. Again, don't worry about the signs, just worry about subtracting the numbers. But now, how do I know what sign to keep? Well, again, for intuition, we can think of if we owe more money, well then we're going to end up owing money. But if we owe less money than we have, we're going to end up with some money left over. So it has to do with which number has a bigger absolute value. So if the two numbers have opposite signs, subtract their absolute values and keep the sign of the number with greater absolute value. Okay? Not the greater number, because here 2 is greater than negative 3. Okay? It's further to the right than negative 3. 2 is greater than negative 3. But we didn't say the numbers. We said the sign of the absolute value of the numbers. The absolute value of 3 is 3. The absolute value of 2 is 2. Right? The absolute value of negative 3, well, that's also 3. So here, this number has the biggest absolute value. Ignoring the sign, which one has the bigger size? Oh, it's got to be that one. So that one would stay negative. Okay. Let's see some examples of this. Let's say I'm going to add 5 plus negative 12. Let's say I'm going to add negative 16 plus negative 4. And let's say I'm going to add negative 12 plus 9. Okay. All right, so now these have opposite signs. Okay, so the two numbers have opposite sign. We're going to subtract. 12 minus 5 is 7. Okay, but now keep the sign of the number with greater absolute value. Here, negative 12 has a greater absolute value than 5 does. It's bigger in size. And since that's a negative, my answer is going to stay negative. Here, the two numbers have the same sign. Both are negative. Okay, so here, the two numbers have the same sign. I'm going to add their values. 16 and 4 make 20. And then I'm going to keep their sign. Since they're both negative, in the end, my answer is negative. And here, again, opposite signs. All right, so when they have opposite signs, subtract their absolute values. 12 minus 9 would be 3. And now keep the sign of the number with greater absolute value. Oh, again, this 12 has the bigger size. It's the bigger absolute value. And since it's negative, your answer will stay negative. Okay. Go ahead and give that a try. Go ahead and add the following set of numbers. 9 plus negative 5, 12, negative 12 plus negative 7, and negative 12 plus 7. All right, go ahead and give those a try. Pause the video if you need to, and then once you have a result, go ahead and unpause and we'll confirm those together. All right. These two, they have opposite signs. Okay, so we're going to subtract. 9 minus 5 is 4. And now, which one has the greater absolute value? Oh, it's going to be this one. 9 is greater than 5. So, since that's positive, your answer is going to stay positive as well. Now, thinking about it in terms of money, you have $9, you spend 5, you still have 4 left over. Okay. These have the same sign. So we're going to add their values. 12 plus 7 makes 19. And since they're both negative, we're going to keep that sign as a negative. Think about it as money. You owe $12, and then you owe another $7. Total, you owe $19. And then here, again, you have opposite signs. So you're going to subtract. 12 minus 7 is 5. And then you're going to keep the sign of the number with greater absolute value. Negative 12 has a greater absolute value than 7. So you're going to keep the sign of the negative 12. So your answer will be a negative 5. And again, in terms of money, you have $7 and you spend 12, well then you're overdrafted. You overspent by 5. You owe $5. Keep in mind that this will continue to work regardless of what type of numbers you have. If you have integers like we have here, okay, that works fine. But it also works for fractions and decimals. So for example, let's say we're going to add the following decimals. 6.73 plus a negative 4.19. And let's say we're going to go ahead, well, let's just do one at a time here. Let's go and try this one. We're going to add these two numbers, okay, but they have opposite signs. So really, we're going to subtract the absolute values. So 6.73 minus 4.19. Okay. Here you cannot borrow. You cannot subtract because you're going to need to borrow. You can't take 9 from 3. So you're going to borrow 1 from the 7. It's going to become a 6. And 3 becomes 13. So now 13 minus 9 gives us 4. 6 minus 1 is 5. And 6 minus 4 is 2. So that's going to be 2.54. Now we've subtracted. Now we want to keep the sign of the number with greater absolute value. Here, that number has greater absolute value. Oh, but it's positive. Okay, so in the end, my answer is going to be positive. 2.54. Like that. All right. Seeing that one more time. Let's try this. Okay. Let's add these together. Again, we have the same sign. So that means we're going to add the absolute values. Forget about the positive and the negative for a second. Let's just add the numbers themselves. So 12.39. And to that, we're going to add 6.72. Since they have the same sign, we're going to go ahead and add them. 9 plus 2 makes 11, so we carry our 1. 7 plus 3 is 10, plus the one we carried is 11. So carry your 1. 6 and 2 make 8, plus 1 more is 9. And there's nothing to add to the 1, so we just bring that down. Take your decimal. That comes straight on down like this. And so you have your result. It's going to be 19.11. Oh, but since we added two numbers that have both a negative, then the absolute values are going to keep that same sign. And we're going to end up with negative 19.11. Just like that. Okay. So go ahead and give that a try. Go ahead and do the following additions. Let's have you add 4.9 plus a negative 3.14. And then also go ahead and try this one. 6.831 plus, let's make that a negative, plus a negative 9.75. Okay, go ahead and pause the video if you need to. And once you have your result, go ahead and unpause and we'll go through that together. All right, so let's give that a try. We're adding these two numbers, but they have opposite signs, so we're subtracting. That's going to be 4.9 minus 3.14. Okay. Here we're going to need to borrow. You might say, well, there's nothing to borrow from. Well, then that means that that's a 0. Okay, so here we're going to say we can't take 4 from 0, so we need to borrow from the 9. Okay, now that's 10 minus 4. Okay, that's going to give us 6. 8 minus 1, 7. And 4 minus 3 is 1. Take your decimal straight down, and you end up with 1.76. Now, these have opposite signs, so we subtracted them. Now we keep the sign of the number with greatest absolute value. Here, this number has greatest absolute value, and it's positive. Okay, so we leave that alone as a positive. So that is our result right there. Over here, We're going to add these two numbers. Notice that they have the same sign, so we're going to go ahead and add the two absolute values, 6.831 plus 9.75. And now we just add straight on down. 1 is not being added to anything. If you want, you can write a 0 there, or if not, you can leave that off. Either way, 1 plus nothing is 1. 5 plus 4 is 8. 7 plus 8 is 15, so we're going to carry our 1. 9 plus 6 is 15, plus 1 more is 16. Drop your decimal straight down, like that. And so we end up with 16.581. Finally, we added two numbers that are both negative, so we add their absolute values and then keep the negative as part of our answer. And there we go. This will work for fractions as well. Let's say we're going to add the following fractions. Let's say we're going to add 5/12 plus a negative 3/8. Well, again, we're going to add the two numbers that have opposite signs. Oh, we're really going to subtract them. So here we're going to start off by saying we want 5/12 minus 3/8. Okay. In order to add or subtract fractions, we need a common denominator. Okay. So here we can write this as, we can factor out the number 12. 12 is 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. And we factor out 8 as 2 times 2 times 2. And again, if you don't remember these off the top of your head, you can always perform the diagram. You can always create the diagram here. 12 can be 3 times 4, and then 4 is 2 times 2. So you factor it down into prime numbers, and 12 is 2 times 2 times 3. Same thing with 8. After a while, you start doing these enough, you'll start to remember some of these, especially the numbers that are used very often, like numbers from 1 through 12, the ones that appear on your times tables. That should you'll remember those fairly quickly because you'll use them a lot. But if you don't remember them yet, that's okay. 8 is 2 times 4. 2 is already a prime number, but 4 can be factored into 2 times 2. So 2, 2, 2. So now to find a common denominator, we want to make these denominators the same. This one has a 3, which this one doesn't. So let's multiply by 3 there. Do the same thing on top. So now this one is missing a 2 that one has. It only has a pair of 2's. It's supposed to have 3 of them. Okay, so let's multiply that by 2. And now those denominators are the same. 2, 2, 2, 3. Which incidentally, 2 times 2 is 4, times 2 is 8, times 3 is 24. So our common denominator is 24. Our numerators, 2 times 5 is 10. 30 times 3 is 9. Don't forget to change the numerators at the same time as your denominators. That is the single most common mistake we get when we see people adding and subtracting fractions, is they'll find the common denominator and they'll forget to change the top. Right? So you change the bottom, you got to do the same thing on top. So here that's 10 over 24 minus 9 over 24, which is just 1 over 24. Okay, there we go. So to add the two numbers, well, they're opposite signs, so really we subtracted them. Okay, so that gave us 1 over 24. And then we keep the sign of the number with greater absolute value. Okay, and you say, well, which one has greater absolute value? That's kind of hard to tell. Well, look down here. After all, 5/12 is the same as 10/24. And 3/8 is the same as 9/24. So which one's bigger? Now, here it's hard to tell. Here it's a lot easier. Oh, 10 over 24, because it's a bigger number. Okay, so that one's got the greater absolute value, which means that one's got the greater absolute value. And since that's positive, I keep my answer as a positive. So right here, it's hard to tell which one's got a greater absolute value. But when you look at them like this, that makes it a lot simpler. It's got to be that first one. So since that first one's positive, you keep the positive. Seeing that again, we can add two fractions. Let's take negative 4/15 plus a negative 2/9. All right, so same thing. We're going to add these two numbers. They have the same sign, which means we're going to add their absolute values. Notice we're using the same two rules over and over again. If they have the same two signs, there's one thing you do. If they have opposite signs, there's something else you do, and that's it. Those are the only two possibilities. So here we need a common denominator. 15 is 3 times 5. And 9 is 3 times 3. Right, those are the prime numbers that multiply together to give you 15 and 9. Notice I'm not going to worry about the negative because what I want to do is I want to add their absolute values. When you add two numbers that have the same sign, you're going to add their absolute values. The absolute value of negative 4 is 4. The absolute value of negative 2 is 2. Same thing over here. We added the absolute values. Oh, sorry. Since they have opposite signs, we subtracted the absolute values. The absolute value of 5 is 5, and the absolute value of negative 3 is 3. So we're subtracting the absolute values. Okay. All right. So now we need to add these absolute values, but they don't have a common denominator, so we need to change that. Let's multiply this by 5. Multiply this by 3. Now you have a common denominator. 3 times 3 times 5. 3 times 3 times 5. So this will give us 3 times 3 is 9, times 5 is 45. Whatever you do on the bottom, you do on top. 3 times 4 is 12. 2 times 5 is 10. And now when you add these together, you have 12 plus 10. It's going to be 22 over 45. So adding the absolute values gives us 22 over 45. But then, since you added two numbers that have the same sign, you got to keep whatever sign they had. And since they have a negative, your answer will also be a negative. And that is our result. So give that a try. Go ahead and add together the fractions. Let's say 5/18 plus a negative 11/15. Go ahead and add those together. And then also try negative 5/16 plus a negative 7/24. Go ahead and pause the video, give those a try, and once you have an answer to both of those, go ahead and unpause and we'll go through those together. All right, so let's take a look. To add these two numbers, well, let's see. They have opposite signs, so really we're going to subtract them. All right, so let's find a common denominator for those. Yeah? We're going to take 18. And we can factor that out as 2 times 9. And then 9 is 3 times 3. Okay, so that's going to give us 2 times 3 times 3. Leave the 5 there. Okay. Minus, well here, let me rewrite this first. Let me leave it as plus a negative for now. We'll worry about the sign here in a moment. We're going to take 15. We'll do the same thing. In fact, 15 is just 3 times 5, right? We already saw that one, 3 times 5. Okay. So now we're going to need a common denominator. Here, this one only has a single 3. That one has 2 3s. Okay, so we're going to need another 3 and a 2. Okay, so now this has all the same stuff that this one does. 2, 3, 3. Oh, but this one's missing a 5 that one has. So let's go ahead and multiply that by 5. And whatever you do to one, whatever you do on the bottom, you got to do on top. So here we multiplied by 5, and we have to do the same thing on top. Here we multiplied by 2 and 3, so we got to do the same thing on top. Okay, so really this problem is asking us to do the following. It's asking us to take 25 over our common denominator. 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is 90. So it's asking us to take 25 over 90 plus, let's see here, 2 times 3 is 6. 6 times 11 is 66. Also over 90. Okay, well, again, if you're adding two numbers that have the opposite signs, you're going to subtract the numbers. Okay, so 66 minus 25. 66 minus 25, that's what, 41 over 90. But then, once you finish subtracting, you got to keep the sign of the greater, got to keep the sign of the number with greater absolute value. Here, this number has a greater absolute value than this number. So since that number is a negative, in the end, your answer is a negative as well. Okay. Let's try this one over here. Same idea. I'm going to go ahead and factor things out here. Let's try 16. That's 4 times 4. And then each of those factors into 2 times 2. So here that 16 is 2 times 2 times 2 times 2. It's got a negative 5 on top. And then negative 7 over, let's see, 24. 24 is 8 times 3. And even though 3 is a prime number, 8 can be factored as 2 and 4. And 4 can be factored further as 2 times 2. So 24 is 2, 2, 2, 3. And now to give these a common denominator, all we need to do is multiply this one by a 3 and this one by a 2. Now they're all the same. 2, 2, 2, 2, 3. So that looks like that common denominator is 48. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 times 3 is 48. So this gives us negative 5 times 3, that's negative 15 over 48, plus 7 times 2, that's negative 14 over 48. And when you add two numbers that have the same sign, okay, we're going to go ahead and add them together. 15 and 14 make 29. But then you keep the sign that you started with. Since they're both negative, your answer is going to be negative. Just like that. Okay. Note that it works the same way as whole numbers and whole numbers and decimals do. To add two numbers, if they have opposite signs, you're subtracting the numbers. Keep the sign of the greater absolute value. If they have the same sign, you're just going to add the two numbers and then keep the sign that you started with. If they're both positive, your answer is positive. If they're both negative, the answer is negative. The fact that you needed to find a common denominator is separate. The fact that you need to find a common denominator has to do with the fact that you're dealing with fractions. But the addition of real numbers really is just two rules. You've got to remember these two, and it will apply to any and every real number that you can think of. Now, occasionally in problems, you will have instances where the addition is not written symbolically, but it's stated in words. There are a few words that tip you off that you are dealing with this. You're dealing with this anytime you have the words sum. The sum of two numbers means you've added the numbers together. Anytime you see the word plus, 7 plus 5. That means you're doing this together. You could say add or added, and again, you're putting things together. So for example, what is the sum of 8 and negative 15? Okay. You can always change that into symbols. When you see the word sum, that means you're adding things. Well, what are you adding? Well, you'll see sum of. Where we see the word and, those are the numbers you're adding together. So here, the sum of 8 and negative 15. And so now we can add those. Here we have two numbers that are being added. They have opposite signs. So we're going to subtract the numbers. 15 minus 8 is 7. And then keep the sign of the number with the greatest absolute value. Okay, negative 15 has a greater absolute value than positive 8 does. So since negative is the sign of the number with a greater absolute value, that's also the sign of our answer. What is 3/8 added to 1/2? And again, added or added to, I forgot to write that one down, added to is the same thing. So 3/8, 3 over 8, added to plus 1/2. Here we're adding two numbers that have the same sign, so we're just going to add the two numbers and keep the same sign. All right, so let's go and add these. We're going to need a common denominator. Notice 8 is 2 times 2 times 2. We saw that one earlier. 8 is 2 times 2 times 2. Notice that the number 2 is already prime. So there's nothing you can do to factor that any further. You just leave it the way it is. And notice that here, the common denominator is going to be the number 8, because this one doesn't need any more factors in that denominator. It already has everything this one does. So really, this one just needs to be multiplied by 2 and by 2 again. And now they have the same denominator. Okay, so that's going to give us 3/8, which that one didn't change, plus 1 times 2 times 2, that's going to be 4/8. And now you add those together. They have a common denominator. That's going to give you 7/8. And since in the end they're both positive, well, then your answer is going to stay positive. If you add two negatives, your answer is negative. And when it's one of each, you subtract them and keep the sign of the number with greatest absolute value. Notice that's the exact same rule no matter what my numbers look like. And that's it. That's adding of real numbers. Anybody has any questions, comments, problems, please make a note of those. Reach out to me and let me know. And I hope you all have a nice day.